I'll try and share my screen. Last week we started chapters 2 and 3. We were on chapter 3, and then we had to stop due to time. And like Daniel just rightly mentioned, we'll be starting from facets, but just as a recap, we learned about, for those just joining us newly today, I'm Olusola Adeyemi. I'm a postdoc in the Department of Geography, University of the Free State, here in Bloemfontein, South Africa. And I'm taking chapters 2 and 3 of the R for Data Science book. We started last week, and hopefully we are going to wrap it up today, and then we continue the other chapters subsequently. So last week we were able to go through the general frame of a ggplot, and then we saw how the function is being presented. It carries a mapping, and then the mapping carries the aesthetics. The aesthetics carries the X and the Y, which is the coordinates. And then within the aesthetics too, we could have color, and then we could also vary the color with discrete variables. We'll still see some of these as we go on. I don't want to waste time, so that I don't want to go back and forth, but still see some of these general frame as we move on in the course of the chapter 3. So today I'm going to kickstart by going through facets and then the other subsections for this chapter. So with facets, it's another way to add additional variables to the aesthetics. We already know that we can use color to add additional variables. Now with facets, we have two major ways. We can use the facet underscore wrap function or the facet underscore grid function. The variable that we pass into the facet underscore wrap has to be discrete as it is here. And then we would see for facet underscore grid subsequently. Now, this is the general function that we learned last week, the ggplot. Then you have the data. The data in question here is MPG, which has to do with characteristics or attributes of cars, taken in the United States of America. Then we have the geom point. This is the function that tells us that it's a point. It could be a line or any other thing, but for now it's a point. And then this geom point carries mapping, and then the mapping goes with the aesthetics, and the aesthetics plots the X and the Y. The X and the Y in this case is the displacement and the highway gallons per liters, I think. And now we are now adding a new function here, which is the facet underscore wrap. And like I said, it carries it should be a discrete variable. And here we have class. Here the class here is the class of the vehicle. If I'm still right, but we'll see what the class is here now. But the major thing is it has to be a discrete variable. And then you have this style function or this style symbol before the class, and n row is just saying it should be in 2 rows. So we run this now, and then see the output. Okay, so just a minute. Okay. Okay. Okay, so while it's still loading, it should pop up any moment from now. The other aspect to facet underscore wrap for the facets, okay, so here we have it. It's like we are plotting 3 dimensions we have the highway liters, in gallons for the vehicle. We have the displacement, and also we have a third variable, which is the class of the vehicle. So we are using the facet underscore wrap now to break down the scatter plots into each point. So this is showing two-seater vehicles within, relating it with displacement and then the highway in gallons. This is showing vehicles that are compact. This is showing vehicles that are mid-size. This is showing vehicles that are, minivan. So that's just what the facet underscore wrap, is doing here. Is breaking, the entire scatter plot into classes, and then we are seeing more or less like a 3-dimension, although in a 2-dimensional plane. Now, the other aspect is the facet underscore grid. However, for the facet underscore grid, it's going to bring in, it calls in 2 functions, which is more or less like a formula. The facet underscore wrap brings in a discrete variable. However, the facet underscore grid, the formula should contain 2 variables, separated by this style function. The entire structure remains the same, the ggplot, the geom point, and then we call the facet underscore grid. But in this case now, we are going to relate it with 2 variables, and then we plot. Now we see, now here is like 1, 2, 3, like 4 dimensions. We see the drive. Is it a 4-wheel drive? Is it a front-wheel drive? Is it a rear-wheel drive? And then we see the class, and then we see the SYL. I can't remember what this is immediately. Okay, we see the SYL, which stands for, okay, it's going to bring it up now. And then we see the displacement, and then the highway, the gallons per liter. Okay, so this is showing SYL is yes, number of cylinders. Yes, so we have the number of cylinders 4, 5, 6, 7, 8 on this axis, and then we have the drive here to my right hand side. Then to the left we have the HWY. HWY is the highway miles per gallon, and then here we have the displacement. So it's like we are seeing a plot of 4 dimensions, and then it's now associating each of the points, to the intersect of these of these associations. So that's just what facet does. It tries to break down the 2-dimension, the 2 scatter plots into classes or into structures based on either we are using facet underscore wrap or facet underscore grid. Now, if you prefer to not facet in the rows or column, then we can use a full stop instead of a tile, instead of the plus variable. Now we see this here now. We have a full stop here in front of the tile, and then this is going to give us something like this. So yes, if we remove this, if we remove this now, yes, this is what we have. So this is saying if you prefer to not facet in rows or columns, if you don't want to specify whether it should be in rows or columns, then you can use a point instead of a variable name. So the general idea about facets is that it takes 2 attributes, facet underscore wrap and then facet underscore grid. For facet underscore wrap, the variable has to be discrete. However, for grid, most often than not, you should compare it with 2 variables, and then it breaks it down, and then we can see, like a 4-dimension relationship between the points. Now we have some series of exercises. I've done most of them, so I'll just go through. Now the first question says, what happens if you facet on a continuous variable? Now this is what this is saying. If you have a continuous variable, yes. So if you put a facet on a continuous variable, which is not something that should be done. So it turns the continuous variable into a categorical variable. It sees it as a categorical variable. So it breaks it down into 9, 11, 12, and then tries to match the points with it, which is not aesthetically presentable, and is also not a bit is not largely reasonable, because it's a continuous variable. It's not a categorical variable. So that's for that. Then the second question says, yes, we have some empty cells. We have empty cell here. Yes, this place, here we have an empty cell. So the question is, why do we have empty cell? It's pretty straightforward. That means that engine size is the engine size now, CYL. So yeah, yes, number of cylinders. That means there is no variable that has a 5-cylinder and that it is also 4-wheel drive. So there is no variable that is intersecting at this point. No. Likewise, also there is no variable that is intersecting between highway miles and then displacement at that point. So that's why we have a blank. That's why we have a blank space within that plane. Okay, so and that's the same thing I've done here, just to show why we have this plot here, just to show why we have a blank space there. So the third question says, what plots does the following code make? Okay, what does full stop do? Okay, so we can look at the plots. This is the first one. Okay, and then this is the second one. Okay, so one is horizontal and then one is vertical, and that is the same data, but I'm placing the full stop at different points. Here the full stop comes before the tile. That's why it is vertical, while here the full stop comes after the whole structure. We have the drive, then we have the tile, and then we have the full stop. So these two statements here changes the position of the graph, whether it's going to be vertical or whether it's going to be horizontal, and that's why we have it the same graph, but in different formats. Okay, so
really quickly,
the next
quick question. Can I
ask
you? So I think you mentioned this before, where you took the full stop out and it kind of gave us the same result. What is the point in putting the full stop? Do you know?
Okay, the point in putting the full stop.
Yeah.
Is that the question? Yes. Yeah. Okay, that's exactly what this plot is saying. Okay, here is facet grid. Here is the drive of the vehicle, whether it's a 4-wheel drive or okay. So let me use the same. Okay, so if I plot this, so it's actually the same. We are looking at the same graph, but in different orientations. This is slanting or slipping, whereas this is vertical. So now, depending on choice and depending on depending on choice and depending on aesthetics, although yes, this is like the most preferable, but yes, some can also present like this. So the only thing that determines whether it's going to be bedded or whether it's going to be standing is where the point is placed. Here the point is placed after the tile at the end of the whole statement, but here the point comes immediately before the tile. That's why you have those two different presentations. Okay, does that answer the question? Okay,
because I think in a previous example you removed the point and it still showed the same result. So what is the purpose of the point, I guess is my question.
Okay, yeah, the previous example, I actually didn't change the orientation. You're actually talking about this example here. Okay, I think it's the one before. Yes, this one here. So what I didn't do here is, this is like this. Then what I should have done here, I should have shown this, and then this would have happened. Do you get the difference now? Okay, so yeah, so that's what the point does. It changes the position of the graph. Now, take the first faceted plot in this section. Okay. Yes, we have to look at this plot. We know what this is now. This is facet wrap, according to class of the vehicle, and then n row. That means it's going to be in 2 rows. So we have to look at this plot, and then what are the advantages to using faceting instead of color aesthetic? So from last week class, we know we can also use color, as an aesthetic. If I plot this now, okay, so this is color, but let me use the same. Okay, let me use the same. Okay, so let me use drive. Is it drive or class? Okay, class, sorry. Okay, class. So the question is, what's the difference? Which is preferable? Okay, so we are seeing the same plot, unfortunately. Okay, let me try and bring it to on the same page. Sorry. Okay. All right, let me see if this is gonna do. No. Okay. Okay, so here we have the same plots, not the same plots technically. One is using facets, and the other we are using color. So the question is, what are the advantages to using faceting instead of color aesthetics? So they are both breaking it down. Here we see two-seater, and then we see the relationship between two-seater, displacement, and highway miles per gallon, ditto for subsequent plots. And here also, we see the same thing, but yeah, in different colors. They are basically the same plots anyway, but in different colors. So the question is, what are the advantages? Basically, for color, it's limited. If you can't go beyond 9 for colors, you can't go beyond 9. And then also, for those that have color defects, they might not be able to really pinpoint differences. And then how to really say what's the difference between minivan and pickup might be a challenge. So basically, although depending on what one is trying to pass across, it will determine largely what one is going to go for, but preferably it's better to use a facet, and then here one can easily describe and easily talk about what the data set is saying. Okay, so okay. Okay. All right. Okay, sorry, please. I might not be able to follow the questions on the chat. Okay, so okay, so that's the difference between faceting and then using color aesthetics. So what are the advantages, and then how might the balance change if you add a larger data set? So like I said, if the data set is very large in terms of the class of the type of the vehicle, if it's beyond 9, then you might not be able to use color, because color is restricted to 9. So you might have to yes, you might have to fall back to faceting. So having a point or no point would have the same results. No, it's going to have the same result, but it's going to change the orientation. Like I said, it's going to make one vertical, then it's going to make the other like horizontal. We can also try it, on our own and see the difference clearly. So we have to read the help for facet wrap, and to answer that, what does n row mean? What does n color mean? So n row specifies number of row, n column specifies the number of column. So what other options control the layout of the individual panels? Now, if you go to this help function, we'll see, the other functions that controls the panels for facet wrap. And then why doesn't facet grid have n row and n column? Because it doesn't have, because facet grid deals with the category. So there is no need to specify the row and the column. It deals with the category. It categorizes the data already. So it breaks it down into rows and columns. So there's no need specifying rows and column in this case. Okay. So question 6 says, which of the following two plots make it easier to compare engine size, that's displacement, across cars with different drivetrains? And what does this say about when to place a faceting variable across row or across column? So we are coming back to this, to the question again. So yeah, so this is the same question again. So the question is, which of the following two plots make it easier to compare engine size across cars with different trains? So engine size across cars with different trains. So the engine size is either is 4-wheel, front wheel, or rear wheel, and then across cars with different trains. So I think it depends on the individual, but this is like the most, will I say, the most appropriate, because you can see what you are comparing easily, as opposed to this. Although yes, I think it's debatable though, but it's largely okay. All right. Okay. So so I think it depends on largely the individual, and then what we are trying to portray. Okay. So the last question here says, recreate this plot using facet wrap instead of facet grid. Okay, so this is the plot. Okay, so we have to recreate the plot using okay, facet wrap. Okay, so I've actually done this. Think this was what was here, grid, and then you have something like this. Okay, think this was over here, if I'm not mistaken. Okay, so we have to recreate this using facet wrap. If I'm not mistaken, I guess this was here. Okay. Okay, recreate this using facet wrap instead of facet grid. How do the positions of the facet labels change? Okay. All right. I can't remember clearly what was here before, but let me try and see if I can recapture that. Okay. The position changing, I'm not so sure. Okay. Not so sure is the position change. Oh, okay. So I can't really, I don't really know. Let me check. Sorry, just a minute. Let me check what was here before so that I can perfectly carry out the question. Just a minute. Okay. 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 Sorry, I can't locate this question. I guess I've changed what was there initially, but you can always check through our exercises to see what was there. Okay, so let me just move on to geometric objects. And then here the question says, how are these two plots similar? Now here we have the same points. We have the same, yes, we are plotting the same variable, but we are using different geometric objects. That means we are using different geom points. One, we are using different geoms rather. One, we are using geom points, and then the other, we are using geom smooth. So we have to look at the two plots and then to see what exactly is different. Now, this is the first one. We are familiar with this, using points. This is the second one that is just being introduced using geom smooth. Now, this is using a line, and then you can see the confidence interval, which is the gray area. Okay, so this is basically what a geom line or a geom smooth looks like, and then it will be discussed subsequently. Now, both plots contain the same x variable, the same y variable, and they both describe the same data, but they are not identical. They use different geoms to represent the plots. Now, a geom is the geometrical object that a plot uses to represent data. And like I said last week, it could be a line, it could be an area, it could be a point, it could be a line, it could be box plots, etc., etc. Now, as you see above, we can use different geoms to plot the same data. Now, like I said, the plots on the left uses the point, while the one on the right uses a smooth geom. Now, a smooth geom works like line of best fit. It's a smooth line that is fitting the data. Okay, so to change the geom in our plot, we have to add ggplot. Okay, so this is what was done. This is the first one, and then this is the second one. Now, this is going to show two different plots because yes, we are adding ggplots separately, but subsequently we see how to plot on the same data, on the same data using points and using line. But here we are going to have two plots. One is the point, and then the other is the smooth line, which is more like a line of best fit, or a line of best fit. Now, every geom function in ggplot takes a mapping argument. Yes, we already know that from last class. Takes a mapping argument that is aesthetics. Okay, thanks for that. Okay, so every geom function in ggplot takes a mapping function, and then the mapping carries an aesthetics. However, not every aesthetics work with every geom, and that is what you are going to see now. For line, they don't carry okay, sorry, there's another question. All right, thanks. Okay, so for line here, we see the ggplot, we see the geom smooth. However, we have what we call the line type, which is different from what we've been seeing from previous sections when we are using points. So here the line type now carries drive, just like we did for points, using color, or yes, using color. We can use color if it's a geom point, something like this. If it's a geom point, okay. Oh, sorry. Okay, excuse me. Okay, so if it's a geom point, so we have something like geom point, we have mapping, we have aesthetics, then we have our x is equals to displacement, then our y is equals to hwy, and then we have color is equals to the rv, something like this. And then yes, so this is for a line, for a point rather, this is for a line. So the difference here is the smooth, no, wouldn't go with the color here, but it's going to go with line type. And then the line type here now carries the discrete variable drive, which is also going to break it down, no, and then we have the confidence, no, interval for each of the lines. And then here, like it's just what I've just said. Now here, the geom smooth separate the cars into 3 lines based on their drive values, which describes the drivetrain. One line describes all the points that, you know, with 4, that's with 4-wheel drive. One line describes, you know, the front wheel, while the other describes the rear wheel. Okay, so yes, so if this sounds strange, we can make it more clear by overlaying, yes, the lines on top of the raw data and then coloring everything according to drive. So what was done here is to do an aesthetic map. Here they call it the global, yes, this is the global condition. And then you have a geom point, and then you have a geom smooth. Now this function here is going to override this statement, so that you are going to, so that we have the lines showing across the points. So we have something like this here. So despite the fact that we have a global statement here that should have worked for the geom point and the geom smooth, but because we have an extra condition here, then we have each of the lines having its own smooth, line across, you know, the drive using a line type. Okay, so yes, something that we notice with this plot is that it contains 2 geoms in the same graph. And then yes, we'll see what we can do with this subsequently. Now, many geoms like geom smooth, you know, use a single geometric object to display multiple rows of data. Here we see that line type is what yes, we see line type here. For these geoms, you can set the group aesthetic to a categorical variable to draw multiple objects. Okay, so ggplot will draw a separate object for each unique value of the grouping variable. In practice, ggplot2 will automatically group the objects for these geoms whenever you map an aesthetic to a discrete variable, such as is done, you know, in the previous example using the line type. Now, it is convenient to rely on this feature because the group aesthetic by itself does not add a legend, you know, or distinguishing features to the geoms. Now we'll see what they are trying, what that statement is trying to say now. Okay, so we have 3 different geom smooth. This is the first one, which is what we are used to, or which is what we've seen in the previous example. Now this is the group, and then this is the last one using color, and then using geom smooth, and then making mapping, and then passing color as drive. However, the show legend is set to false, because if we set this to true, it's only going to show for the last plot, which is not going to make sense. For, you know, we are having 3 plots, and then it's only one that is carrying the legend, which we wouldn't be able to interpret, you know, the other 2 plots. That's why, you know, it's set to false, and it's because the group, as mentioned earlier, doesn't carry a legend. However, subsequently we'll see how to bring in, you know, legend in our plot. Now, to display multiple geoms in the same plot, add multiple geom functions like we've done in the previous example. This is another one. Here we have the data, and then we have the geom points. We also have the geom as a smooth line. Here we want to display it on the same data. So this is just a simple way to do it. If we want to separate it, then the geom smooth has to carry another ggplot statement so that we would split the plot into two. But this is how to present it on the same plot. We just make the statement geom point and then add that to the statement geom smooth, and then we have the same plot on the same plane. This, however, introduces some duplication in our code because yes, we have to type for geom point, and then we have to type for geom smooth. However, there's a way to avoid this, and the way to avoid that is to have the global, what they refer to as the global line or the global function. So this is the global function, the ggplot, the data, then it carries the mapping and the aesthetics, and then we pipe, or we add the geom points, and then we add the geom smooth. So here we are going to have the same form. We are going to have the same plot. Yes, we are going to have the same plot. Yes, with less coding. Yes, with less coding, which makes room for parsimony. So we have the global statement here, and then we have the default function for geom point, and then we have the default function for geom smooth. However, like I said previously, each of these can also carry their own local functions that will override what has been stated in the global function, which we would see subsequently. Now, if you place mappings in a geom function, yes, ggplot will treat them as local mappings for the layer, which is what I've just said now. So it will use these mappings to extend, override the global mappings for that layer only. And yes, this is sorry. So this is a typical example. We have the global mapping here, and then for geom points we have a local mapping, which we are saying should color according to class, and then we have our smooth. So it's only going to affect the points within the plot. It's not going to affect the line. So it's going to color the points because the point is carrying another mapping aesthetic. So it's going to color the points according to different classes, and then it's going to still plot the line. Okay, so the local function for the mapping for the points is overriding the global function that is contained in the ggplot. So we can use the same idea to differentiate different data for each layer. Here, our smooth line displays just a subset of the MPG data set. The subcompact cars can also be shown, and this is what was shown here. So here we see the global function, which is the aesthetics showing the X and the Y. And then for the local function, we have the point saying it should color our class. And then for the smooth, if you remember, we introduced filter last class. So it's saying filter from MPG, filter class, and then bring out subclass, subcompact. So our line is going to be along subcompact, and then the standard error is false. So here we'll see, we'll still talk about the standard error subsequently. So here, so we'll see subcompact. So it's filtering only subcompact. So the color for subcompact, so it's only working along this line here, is only fitting for subcompact. So we can change this here to two-seater, and then it's going to fit along the two-seater. Yes, so it's going to fit along these two-seater points alone. So that's what this is saying. It's going to filter just for that particular point within the frame. Okay, so yes, so that's how to use local and then global within the same function for ggplot, and then for any of the geom functions that we are working with now. We've learned how to use filter in subsequent last week, but here is introduced here. For now, we just know that the command selects only the subcompact class or any of the classes that we want to deal with. Now we have series of examples here. This one says, what geom would you use to draw a line chart? Now I've presented different ones. For box plot, we have geom box plot. For histogram, we have geom histogram. For area, we have geom area. For line, we have geom line. Now this says we should run this code without plotting it, and then we should interpret what's going to happen, and then we plot and then see. So this is saying, okay, data, we are mapping global, then points, then smooth. So here we are going to have points, and then we are going to have a general smooth line, and then the point is going to just be the point is going to be there, but the color is going to be along drive. So different drives is going to have different colors. Okay, let's see. Okay, so yes, and I also didn't. Okay, yes. So because this is the global function, is going to also affect what smooth is going to do. So smooth is also going to plot, for each of the drives, and then the point also is going to differentiate along each of the drives, because this is the global. Yes, this is the global function. So it's going to affect these two subsequently, since we are not overriding it, with any local function within the subset. Okay, so then, okay, what does show.legend false does? So show.legend false would suppress would suppress the legend. It won't display it. If you set it to true, then it's going to display it. What does SC argument to geom smooth? What does it do? It adds standard error bands, to the lines, and with these two graphs look differently. Okay, so we can look at the graphs. This has a global statement, and then we have points, we have smooth. Then this ggplot, okay, smooth, okay, shouldn't look different. Yes, it shouldn't look different, because it's basically saying the same thing. Shouldn't look different because basically saying the same. What they've just done is, rather than using a for parsimony, like we learned the other time, this is reducing the number of typings you have to do, while this is just making a statement for each of the points and for each of the smooth. So it's basically saying the same. It's saying the same thing. Okay. Now we have series of plots, and then we have to write the codes. Yes, but yes, we have this. We know this is just our normal plot. Now this is using group. This is here. This is the second one here, using group, as drive. Then this we are familiar with. This is just breaking is a general statement that is saying the color should be drive, and then we are going to use the default function for smooth, and then the default function for point and for smooth. This is this one here, and then here we are only showing for one of the points. So there is a color along here, 1 2 3 4. So this here, yes, there's a color along drive. Okay, we've answered this. Okay, this one is using a line type for the drive, but yes, it's using a line type for the drive, but it's suppressing the standard error to false. Okay, and then it's also using a color. It's also breaking the color according to drive, which is this, yes, which is this, and then this is using a, this is using a line type for the drive. So we are going to have different lines for each of the, for each of the drives. And then this last one is introducing a color to the point. So we can also try to, now on spare time, try to go over some of these exercises and then see how far we can go. Then here we have statistical transformations, but here we'll be using the database called Diamonds. Now we want to talk about bar charts using GeoMBar, and then we want to talk about Diamonds, and then the data is Diamonds, and then here the mapping, we will not be having X and Y because it's bar charts. So the X here is cut. Cut is one of the attributes in the Diamond database. We can look at it, at our own spare time. And then if you plot this, we see a simple bar graph, using counts. And then we have the cuts. This is the cuts attributes: fair, good, very good, premium, and ideal. Now, the x-axis displays the cuts. On the y-axis, it displays the count. However, if you open the Diamond database, there is no count. That means there is a transformation that has been performed, by binding this fair, good, very good, premium, ideal into counts, by count, into counts, something like frequency, and then, providing this statement. So, yes, what was done pictorially will be presented here. So this is the transformation. Here there's no count, but this is just normal statistics. It does a regrouping using a stats function that is embedded, within that is embedded within it to now produce this GeoMBar. Now we can learn that the start a geom uses by inspecting the default value for the start argument. If you use GeoMBar, if you go to help for GeoMBar, then you see the start is a count, which means that the GeoMBar uses the start count. Now the start count is also is well documented, and then if we scroll down, if you go through the GeoMBar help, we'll see how it's compute its variable using counts and then proportions. So we want to use the start count now and see what is going to give us. So it's still going to give us the same. It's still going to give us the same thing, as GeoMBar. So for the GeoMBar and the Geom and the start count, they use the same. They perform literally the same thing. Actually, what they will say subsequently is that for every geom function, there's a corresponding start. There's a corresponding start functions, and there's a long list of that was provided in the exercise. Now, this this works. Is just what I've said now. Okay. Yes. Now we have another example here. A table was created. However, if I create this table now, my stem is going to hang. I don't know why. A table was created using Tribble to create a table of cuts and then frequency, and then to plot this. Now, if you plot this, we are going to have a table showing cuts and frequency rather than counts and proportion or cut. Yes, rather than count. So here we are going to have the frequency, and then we are going to have the cut, because here we specify the X here, and then we specified our Y using start identity. Now, this is something we can also still go over to see what exactly is being done here. Now, We might also want to override the default mapping from transform variables to aesthetics. And for example, you might want to display a bar chart of proportions rather than counts. Now, here now we have X, and then here we have Y after start proportion. And then this group here is what is actually showing the proportion. And this is what they are trying to say now. If we remove this group is equals to 1, everything is going to be the same. But here now we have the proportion of each of the cuts. If I remove the group now, if I remove this group here, then there is not going to be proportion, most likely. So yes, so there's not going to be proportion. So that's what this does by enforcing the proportion for each of the cut variables, okay, for each of the cut attributes rather in the diamond data sets. Now to find variables computed by the start, we have to look into the section title computed variables in the help section. Now most of all these things are provided in the help section. Also, we might also want to look at we might also want to draw greater attention to the statistical transformation in our code. Now, for example, we might want to use stat summary, which summarizes the Y values for each unique X value. And then here, what they've done is to bring in an extra function, which is the stat summary. It carries mapping, Y, X is cut, Y is depth, but here we have an extra function for minimum, maximum, and the median, which which is going to give this plot, which shows the minimum, the function for the minimum, the function for the maximum, and then function for the median. This is just like a box plot, in a line. We have the median, we have the minimum and the maximum function. Now we have series of exercises, but because we want to finish today, I think I'm gonna have to skip these exercises. But I've done most of the exercises, so I can always share them if there is need. Okay, so we have the next one is position adjustments. Most of all these things are just to show aesthetics, where you color your bar. This is showing cut. The color is cut, so the color is outside. This is showing cut, but it's showing fill. So the color is inside. So the color here is cut, but here we are using fill. So it shows the various variations when you use fill or cut. Then we have clarity, which makes it, which brings this, into the argument. Yes, the cut is the X, but the clarity in this case now also helps to bring some sort of proportion by varying. The clarity is an attribute within the ggplot. By varying it, and then we have the clarity here, and then this is just an histogram. Then we can read for each of this clarity across each of the counts. Then we have position adjustments. For position adjustments, we have identity, we have dodge, we have fill. We've seen what fill does. And then position, we have the identity here, we have position identity here, we have fill here, we have color. So we've seen what this does initially, but we see the position. Let's see the position here. So this changes the position. Yes, so one is having fill, one is not having fill, but literally is the same map, but one is transparent in terms of clear, yes, in terms of fill, and then one is not transparent. Okay, so the position adjustment is more useful for 2D geomes like points, which is the default. However, we can also bring it here. So here also position fill also works like stacking, but it makes each set of stack bars the same height. Like I said earlier on, this makes it easier to compare proportions across groups. And this is just talking about various ways to look at bar charts. Now, I didn't introduce groups here, or groups were not introduced there. However, we are using position as a field, and yet we can see the range for each of the clarity. For each of the clarity. So we can read off each of the clarity, based on the count values. So we could see the bands, and then we can read the values for each of the clarity as it is segmented across the bars. Okay, and then we see position dodge. What position dodge does. Now this performs something like is it component bar charts now? Yeah. So this perform rather than segmenting it, this groups it. Yes, component. I think it's component. Multiple rather. Yes. This gives a multiple bar charts. This is for dodge. Now this is for fill, and then we see identity. Okay, and then overplotting. Oh, okay. I don't think we can finish today, although we are almost through. I don't know. We are almost through. So I what do we?
I think it's fine though. I mean, wherever place we cannot stop, we can always pick it up. I mean,
oh, okay.
Okay. So I think it's fine if we get to. I think we probably have like 3 minutes, 2 minutes, 30 seconds left. So if probably get there, wherever we stop, we'll continue next class. But I'm guessing
okay.
We've kind of had like 2 weeks to go through this chapter itself. So I think most of these things are like, extra points that you're just making. So I think you're right on course. At least that's kind of why I see it. So wherever place we stop in the next 2 minutes, thereabout, I think we're fine.
Okay, so what Jitter does is that the initial plot. Okay, what this if I remove this now, what this is saying is that the point you are going to see is actually less than what is actually meant to be portrayed. So we have less points being shown because of positional adjustments. Now, what Jitter does is position. Jitter. So is to try and adjust, is to try and show each of the points by shifting, in terms of height and in terms of width. So it tries to portray all the points, that is meant to be shown, and that's what Jitter does. It adds a small amount of random noise to each point to show, what is actually meant to be there. Without this Jitter, we have a kind of condensed plot, which is what we've been working with, earlier on. So that's what Jitter does, and then yes, we'll talk about Jitter. Then the exercises, we'll talk about Jitter, and then different ways through which we can position it, and then yes. So yes, the question is what exactly controls Jitter, and what controls Jitter is the width and the height, which is what I've actually done here. The width. I've changed the position width for Jitter and then the height for Jitter for each of these plots, and then we see the differences. One is expanding, then one is growing laterally, then one is like growing, we just see the difference, in terms of width and in terms of height. So that's what basically controls Jitter. And then okay, so we can see the difference clearly here. Yeah, so here and then here. So this is counts. This is just normal counts that we've done. Then this is Jitter, which tries to spread the scatter plots to accommodate other points. Okay, I think someone is saying something. Okay. Okay, so yes, and then the next point is talk about coordinate systems. And for coordinate systems, okay, I think it's a little bit after 7. Okay, I'm already, okay. All right, I think I can stop here. All right, thank you very much. Okay.
I think that's fine. I mean, thank you very much. I think this was actually very good. I mean, I probably speak maybe just myself, but this actually very good rundown. It seems like we've kind of gotten to where we want to be. Maybe my suggestion might be, would we like to finish the chapter ourselves, and maybe just move into the next part, where I guess Matthew is probably going to take over there. I think that's my suggestion. So, whatever you guys suggest, I think that would likely be good. The other points would be, please guys, please volunteer for the classes that we kind of had the spreadsheets. I probably should reshare the spreadsheets. Just give me a quick minute. Let me just look for it. So we kind of had the spreadsheets where we're all volunteering for classes. Adeyemi just decided to go first, which is interesting. But we kind of want to take up the entire spirit again. So if you go through the book club R for data science channel on Slack, you will likely see the spreadsheet itself that we had created. So you could just put your name in, whatever class that you want to take. Thank you guys very much for this meeting. I think this was actually very awesome. Thank you again, Adeyemi. You've actually been very fantastic in these first 2 sessions. Have a very good night, guys.